So we are using a optical flat. Here these are one set of optical flat. This is another type with bigger dia. This is another one. So we can use this optical flat as a reference for checking the flatness of fine reflective metal surfaces. So you can check the flatness. So we are using, for checking the flatness, we are using optical flat plus monochromatic light. So this is monochromatic light. So we are using the principles of interference. This is a sodium vapor lamp. So this lamp light falls on this one optical flat. The optical flat resting on the finished metal surface. So interference will occur. So due to interference, we can see dark lines, consecutive dark lines and bright lines. This one, dark line, then bright line, again dark line, like that. Parallel lines form. If these lines are parallel, you can see the surface is perfectly flat. If there is undulation over the surface on the pattern for this fringe pattern, we can say that surface is irregular. Surface having some deviation from the flatness. That by counting that deviated lines, we can say how much micron it is deviated. So this flatness difference of the order of wavelength of light used is only on that range we can measure. Not for rougher surface, we cannot use this surface. Use this optical flat. Only flat reflective surface with a fine surface, and then within that range of the wavelength of light used, we will get the variation. You can check the phase of micrometer. This is on continuous usage. Phases of the micrometer will run out. So we can check whether the surface is run out or not. Otherwise, you have to lap to get the phase get corrected by lapping. So just place here. You can see the fringes, these parallel lines. This is other phase also having slightly curved. So that means slight variation, flatness error is there. I have to lap the surface to get the variation corrected. So this accuracy, there are 4 types of optical flash that is specified. There is a standard wavelength, that is 632.8 nanometer. With respect to this wavelength, lambda is, we are specifying the accuracy 1/4 of this wave, 1/4 of lambda first, then 1/4, 1/10th of lambda, 1/20th, 1/60th. This 4 types of accuracies available. This into this wavelength. With respect to this one, we are specifying the accuracy of the optical flight. So the principles is the gap between these two waves is half the wavelength. This waves, this is the fringes, then with this fringe and this fringe, this distance gap is half the wavelength. You count the number of fringes on that surface. Here we are getting 3 fringes, 2, 3, half of this or something, 3 fringes. So 3 fringes into half the wavelength. 3 fringes into half the wavelength, 0.75 micron we are getting. So by just observing the fringes, we can say that, but we know the wavelength of the light used, then we can say how much surface deviation is occurred. If there is curved surfaces, you can see more. If the surface is very steep, the fringes will come closer. So surface, it is very steeper, then fringes will come closer, and flat, then there is more gap between them. So if for even surface, you will get straight parallel lines. You can check irregular surface. So you can try to check the this is some irregular flat. So you can check. So this, you see, this is curved. Usually if the surface is flat, you will get straight lines only, but this is curved. So within a 2 straight line, you have to count how many curved lines are there. That into half the wavelength of sodium light, you will get the surface deviation. You can see on this micrometer face, it is also very curved. You can see steep curves are there. So if we are using this type of micrometer, we will get different readings. For the same specimen, we will get different readings due to this surface irregularities. So other face also very curved. So this is a inspection tool. Quickly we can check after grinding, finishing and lapping. We will get the reflective surface, measuring faces, measuring surfaces, and by keeping that we can check whether it is flat or not. So for this purpose we are using monochromatic light, hydrogen light or helium light or sodium vapor lamp. So this is producing monochromatic single wavelength light. If we are using single wavelength light, then only we will get bright lines and dark lines. Otherwise the fringes will be colored. The fringes will be formed in 7 colors. So very difficult to distinguish. For this one we have very distinct lines we can see. Dark line, alternate dark line, bright line, dark, in between bright, then dark, and the gap is in between 2 lines is half wavelength of light. So that is a proper interference, that is a property of light, and you already studied. So that comes, and there is a difference, and also the surface should be reflective, then only the interference will take place, because light falls in, suppose this is the case, light falls in this direction, and this will reflect, again reflect in the same direction. So there is a distance gap, this much distance gap. This is reflector, this direction, this reflector in this direction. There is a distance gap. This much gap is there. If this gap is half wavelength of light used, we will get in dark lines. Half wavelength or multiples of half wavelength, we will get dark lines. Otherwise, in the full wavelength, then we will get bright line. So that is, if the light waves are in phase, we will get constructive, because light waves in this manner propagating in this manner. If all the waves are propagating in phase, you will get a constructive interference. If this is out of phase, if it is half wavelength difference, you will get like this. So at that last point we will get a dark line. So that is the destructive interference. Due to constructive and destructive interference, we will get the fringes. So this is the method of inspection using optical flat. So this material used is usually fused quartz, as strain free fused quartz, or theodolite or another materials are also using. Pyrex, not Pyrex, other materials Pyrex or quartz, fused quartz, and surfaces are very perfectly flat. Two surfaces, the top and bottom surface, are perfectly flat, and bigger sizes are also available. So for laboratory purpose we are using only this one. Bigger sizes are available, and smaller sizes are also available. Smaller than this one are also available. So we can use, depending upon our use, you can select the optical flat. Studying the use of optical flat. Optical flats of different height. So this is a perfectly flat surface, and you can use this as a reference for checking the flatness of finished surfaces, lapped surfaces, or polished surfaces. Usually, uses of measuring instrument, you can say.